Good afternoon, everyone, and welcome to today's webinar, Measure, Control, and Connect with PMX, the new dimension in industrial measurement. Your microphone will stay muted throughout the presentation. If you have questions, we will address them at the completion of the presentation using the Q&A feature of WebEx. However, you're welcome to type in the questions at any time. Our presenter today is Sujit Basu. Sujit is HBM Test and Measurements Business Development Manager for North America. He has a PhD in physics, where his thesis focused on materials characterization. He has over 20 years of experience in the data acquisition industry. Sujit, it's all yours.
Thank you, Krista. Hello, everybody. I welcome you to the presentation of Measure, Control, and Connect with PMX, the new dimension in industrial measurement system. As Krista mentioned, my name is Sujit Basu, and I'm a business development manager at HBM in North America. What we're going to cover today is what is PMX, its architecture, its measurements, capability, what type of connectivity it has to the outside world, scalability and synchronization with more and more channels coming in, and of course the most important question, who could use PMX? What value does it add to you? And then we'll jump into applications and what industries it serves, the various applications that we have deployed and where you can use it. And towards the end, I will give you a description of the software and give you a demonstration as well of a specific application, followed by a summary, and then we can open up for a Q&A session. So what is PMX? PMX is a data acquisition and control system for use in production control and industrial test benches. So it is strictly or clearly geared towards industrial applications as opposed to traditional data acquisition system, which is more geared towards laboratory-based application or in the lab or outside of the lab in a mobile environment or rugged environment and so forth. Most people who will be using PMX would be looking for a better quality of manufacturing, such as during manufacturing processes, they can have tighter tolerances, they can maintain tighter tolerances, thereby giving them a better yield. For people, for industries where time to market is important, the traditional way of doing things is you do manufacturing, then you go offline, and then you're testing. PMX kind of gives you an opportunity to do the testing at the end of the line, so it saves you in time and hence time to market. And when cost savings is needed, in some cases a post-testing may not even be needed if you can qualify your production during the manufacturing process. The applications that PMX is well suited for is, of course, manufacturing monitoring, test rigs, functional test stands, and condition monitoring. But not to be too far away from the PMX and data acquisition industry, PMX does bring in laboratory-grade measurement for industrial applications. As I will go through my slides, you'll see some of the features of that. And it offers an easy-to-use and flexibility out of the box. So the software interface and the programming aspects of it is real easy compared to what you may or may not be used to in the current market. Here's the high-level architecture of the PMX, the block diagram as they call it. You've got the sensors that you connect to the PMX, the various types of sensors, and then you have the front end, which is where the amplifier for the PMX is located. This is an HBM class amplifier, which is one of the best known out there. And then you have the buses at the bottom. You can see the various bus connectivity. The back end has a CPU, FPGA, and a digital signal processor with an open 32-channel computational capability. I think this is the brains of the PMX for your application purposes. And I will show you that some of these features that the DSP offers really makes your life so much easier in terms of getting the system up and running literally in no time. And of course, the entire system has a communications bus such as Ethernet, which talks to your computer, an USB bus for data storage and IOs, a CAN bus, as well as a synchronization bus. So what type of measurements does PMX offer? The standard ones that comes with PMX are strain, force, voltage and current, pressure, torque, weight, and a lot more. I didn't list all of that here, but our data sheet shows the more details about the various measurements PMX will offer. But to summarize, what we got here is a collection of input cards, the 401, 455, 460, and output cards along with bus I/O cards. So let's look at PMX cards at a glance. It's 401 is a 4-channel standard analog voltage or current input cards. It is TEDS compatible and has a sample rate of maximum of 19.2 kilosamples a second and 3 kilohertz bandwidth. So that 3 kilohertz bandwidth opens up a lot of different input sensors. The 455 card is a bridge module. It also supports TEDS and has a sample rate of maximum of 19.2 kilosamples a second, but has somewhat lower bandwidth, 2 kilohertz, and mostly bridge sensors do require smaller amount of bandwidth, whereas vibration type of sensors will require higher bandwidth. The 460 can do a variety of sensors, frequency, speed, angle, etc., pulse, coder, SSI, PWM. It is TEDS compatible, has a sample rate of about 35 kilosamples a second and a much higher 6 kilohertz bandwidth. But this card is not released yet. It's coming up at the end of the summer this year. On the output, the 878 is a combination card. It has 8 digital input and output, but also has 5 analog output. So the combination of the 401, 455, and 878 gives you a control system with analog input, digital input, as well as analog output and digital output. There's an Ethernet bus to it, and this is standard on every PMX. So this is on the chassis of the PMX, and you can hook up to any computer and talk to it and see everything what's going on inside the PMX. There are some communication modules that are specific to the application. We offer 3 different kinds. There is a Profinet module. There is an EtherCAD real-time bus module, and then another one coming up pretty soon is the Ethernet IP module. And traditionally, Profinet and Ethernet IP and EtherCAD and all these buses would be available to you to talk to an existing PLC type-based systems if that's what you may be using. If you're not using them, you don't have to use any of these buses. On the PMX, there's also a CAN bus port that gives you CAN open and M12 connector for field modules. Newer CAN options will be released in Q3 of 2013 as well. But I think the biggest aspect of the PMX is the built-in calculator channels. This is a real-time calculator channels on the digital signal processor, so you do not have to do any programming. You can just drag and drop or just point and click and select the math you want to do on the incoming data, and then make some decisions before you send out an output data, whether it's an analog output or digital output. So you've got the traditional MAD channels, you've got behavior channels, generation channels, 2-point scaling, simple 2-point controller, as well as a more complicated PID controller, your matrix calculation, limits, peak values, maximum, minimum, as well as tolerance in band and out of band, amongst more other type of calculations that we are releasing based on new firmware every now and then. So what is the benefits of real-time calculator channels? Why would you care? Why can't you not bring in all the data, the analog input data, digital input data to your computer and then make decisions over there and then send out? Well, you could, but that increases your latency big time. Your computer may not be running a real-time operating system or anything deterministic of that nature. The buses that connect your computer to the PMX or a data acquisition system has another set of delays involved. So by the time you add those up, it is not real-time anymore, and the latencies are much higher. The PMX gives you that onboard reduced latency of information to travel back and forth. So every calculation that you want to do can be done on board of the PMX without bringing all this data back into your computer. And that also takes care of your data management issues. So example, let's say you are assembling an aircraft fuselage. And in assembly of an aircraft fuselage, you are applying forces, but if you apply too much force, you might destroy parts of the fuselage, but if you do not apply enough force, it may not join properly. So a real-time feedback control process that can control this fusing of the aircraft fuselage together is very important. The dynamic monitoring of load and short cycle times leads to peak and average calculations in real time of the load cell or any type of strain gauge that you're monitoring during this assembly process. This makes your quality of manufacturing really tight and done right the very first time. Another example, control system of physical variables. If you're doing voltage control or temperature control and you want to create a two-step controller, you want to create a control system between input and output to keep the temperature the constant temperature, or the voltage is representing a physical variable, you want to keep that at a constant physical variable, then you can use a two-step controller or a PID controller, which is also built in the digital signal processor of the PMX. Let's say you're working on an application that entails disaster prevention or failure prevention, and you do mechanical load monitoring. So a stop limit towards the creeping of that mechanical load would be very important. And you can do that also on this real-time calculator channel. PMX also offers TED connectivity, so if you are going to be using TED sensors, you know that you can connect the TED sensor to any channel one day, and the next day you can go ahead and change it up, and you don't have to reconfigure your sensors anymore because of the TED's property, the TED's chip that's built in your sensor. PMX will be able to read everything that the sensor chip has to offer and reconfigure yourself. FieldBus Connectivity, this is very important if you are trying to bring in PMX to an existing operation that may already have some type of PLC type buses available. So in addition to doing analog output and digital input and digital output, there's, as I said in the beginning, there's the Ethernet bus, but now we also offer an EtherCAT, a Profinet, and the newly to be released Ethernet IP bus. These are directed straight towards interacting with an external PLC system. PMX also has a USB port, and using a USB hub, you can have multitude of different USB devices you can connect to. The primary, of course, usage of this USB port is mass storage, of course, to store data and save your files, etc. But you can also use a barcode scanner for workpiece production ID. The CAN connectivity today that PMX comes with will be expanded to even more using CAN Open, CAN Slaves. So using that, let's say you have a CAN bus connected with 16 channels of analog input and 16 channels of thermocouple and digital output. You can certainly expand the PMX capability in terms of number of channels from what it has already, and add those CAN channels up to go to much higher channels. So in this example, if there's 16 channels of PMX already that has built in here, and you add the CAN channels 2 times 16, so now you certainly have a 48 channel capability. If you were to scale a bunch of PMXs together, you can go up to 20 PMX you can scale together. You need to synchronize them if you want to have all the data in every channel in time sync with each other. And there is a synchronization port on each and every PMX module. There's a sync in and sync out, and you basically use standard Ethernet cable to run the cable back and forth in the daisy chain fashion. You can also connect an external HMI touch panel. You can also connect all of this PMX using a real-time bus such as EtherCAT bus or a Profinet bus, and then talk to external motion control systems or other PLCs. So what value does PMX add? Who could use PMX? Primarily, PMX was designed to do testing. I'm not talking about functional, full-fledged functional tests, but testing during production or manufacturing. The goal here was they give you the option or ability to control your manufacturing tolerances precisely, and thereby making less mistakes and hence increasing your yield. And if you increase your yield, you can reduce your rejects, and hence you save money. So where PMX gained a lot of ground today is a lot of the applications where industries were doing pressing and joining. They like PMX very much because they can control how much force they can use to press and join different metals together. Rolling, punching, cutting metals, fitting bearings and sockets are also other aspects of the same application. In another case, people were using PMX as an end-of-the-line test bench, and this is more for quality control during and after production. In a different application, PMX was used for condition monitoring, and this is for monitoring of the machine that was being run 24/7 and detect when to do preventative maintenance and minimize downtime, thereby boosting efficiency of production system. And of course, the industrial test benches also came in, where they could measure various physical quantities on the test bench, as well as interact with automation system with multi-client capability. This way, they didn't have to tear down the PLC, and they can add to the existing PLC-based system measurement capability using the PMX. How does PMX do it? As I mentioned before, the brains of the PMX is the onboard calculation channel, or the real-time math. But certain things that PMX really plays well is, because it's an industrial environment, is to combat EMI noise and interference in a factory environment, which you have big motors running and many different other RF noise sources contributing towards measurement. And because the PMX amplifier has the built-in carrier frequency technology, it combats such EMI noise very nicely. And you are not going to see any effects of those interferences in your data, thereby giving you the same accurate data that you would have without if you did not have any type of interference. So this is really good. Without any extra cabling, any shielding, the amplifier takes care of all of your issues. Support for good bandwidth and accuracy. So if you have more bandwidth in an amplifier, you can connect more types of sensors. You can scale your applications today from lower bandwidth sensors tomorrow to much higher bandwidth sensors, primarily vibration sensors. More accuracy, of course, will give you more efficiency. This way you can detect which is a pass and fail more accurately without having your numbers all over the chart. A lot of people talk about precision, but what really matters in the measurement is accuracy. And the more accurate your data is, the more accurately your decisions can be made, and hence you can gain more efficiency out of that. Various sensors input for also monitoring applications. It also has analog and digital output for control applications. So the other aspect of PMX is, of course, built-in controls in addition to data acquisition, industrial data acquisition, and easy integration to existing PLC system. Like I mentioned before, that many industrial systems have already PLC-based supported, and you need an external data acquisition system that will just come and plug in, and PMX does it very nicely. And the most important part is that everything here is web server interfaced. So I'll show you some demonstration of that you don't really have to do any programming. Just merely using the web server, you can create and launch an application all from itself. So here's an example of PMX in a batch fitting application. If you see here, we have the bulk materials being bagged in, and there's a motor that controls a measurement signal, which is controlled by the PLC, and then the weighing sensor is connected to the standard amplifier, and the amplifier and the PLC are communicating with each other. You can replace this entire process with just one PMX that will do the control system as well as the measurement system all under one box. Here's an example of an integrated PMX system in a current PLC-based system. If you look at it, here's the entire process that was running before without the PMX. The customer came and said, we need to improve yield in their application and do much more precise manufacturing with tighter tolerances. PMX was deployed. Here's your Profinet cables running for the PLC, and the various analog input and digital input and output sensors connected here. The digital signal processor is in here, and that is doing all the calculation, and here is the power supply. Off you go. We're going to move to the applications portion of this presentation now, and let's talk about the manufacturing tolerance application that I've been talking about in the last few minutes in the pressing and fusing world. In this particular example, the customer goals was to compensate for bending forces during press fitting. Press fitting application can be applied to many different things, but essentially you have a hydraulic or some kind of heavy press coming in that is fusing two materials together. Depending on how hard you press or how soft you press, your material will fuse well or not, maybe reject or an accept. So it is important that you monitor using some type of sensors the pressing process. So here the example was with large sheet metal press, coin press, etc. The input signals connected to the PMX were an HBM SLV 700 strain sensor, and the customer decided to use this strain sensor to measure force indirectly. And the output, of course, was the press control using servo devices and was governed by the Siemens PLC. Obviously, there was a FieldBus involved in this application. And on board the PMX, all we had to do was do a peak detect calculation, which is very simple now. I'll show you in a few minutes. Other measurements that was done was displacement, pressure, temperature. And as you can see from this picture, there's a lot of EMIs in this factory. So the carrier frequency excitation and the amplifiers built in the PMX took care of all of the interference issues, thereby keeping the accuracy tight. And the benefit the customer got was from this improvement increased to 60 to 70 cycles per minute. So that many more presses per minute. We cannot share the actual percentage because of non-disclosure agreement, but that is a big jump for the customer who is doing a pressing application. This is an application for conditioning, and this is outside the factory. This is for wind turbines in the ocean. And here the goal was to do structural monitoring of bending forces during wind loading or water loading. When strong winds come in and strong waves come in, they put a lot of stress on this wind farm. And the idea was for the customer, they wanted to understand how they can make the structure last longer and run longer, so it will make money for them. So inputs were strain gauge rosettes and temperature at various positions. Output was a PLC controlling the wind turbine, doing the pitch control, which is right here in this housing. And the real-time calculation math that was done on the PMX was a rosette strain calculation with compensation. Data logging was on-site via web server and remote stations. And the benefit the customer saw was the structure saw minimal stresses. So whenever strong wind or strong ocean currents were coming in, the pitch of this blade was, in this case for wind purposes, the pitch was adjusted, and that created less stress, and hence the structure ran longer with fewer maintenance trips offshore. Here's an example of ball bearing production. So back to the factory here. The condition was to monitor a ball bearing production. The input here was to measure forces, of course, how hard you press. The output was a digital output PLC for controlling the press. And the real-time calculation that was done on the PMX was fast limit switches and peak detection. And the benefit, speed up and save production and quality. End-of-line test ends, in this case, this is for Siemens electrical switches or switch elements. Examples of such elements are interlocks, safety, triggers. So your power companies are a big subscriber of such elements. And in this case, the input measurement was force and displacement. So you're plotting force versus displacement, as you can see. The output was force and PLC for easy integration to the test control. So you basically control how much force you need to apply based on how much displacement any of these switch elements are moving, either rotatorily or linearly. And benefit for this was the customer was a faster testing of switching with higher yields than offline testing. So here, the testing was done during production, and as opposed to offline collecting all the part that was produced and then starting another line for testing purposes. So this saved the customer a lot of time and money and got the production done right in the first case. If PMX is too many channels for you and you're looking for a lower cost and lower channel type of solution, we have another product called PML. You can go to HBM's website and look it up as well. And this has been there for a long time. It is for precise weighing, batching, and accurate filling type of application, and is widely used in industry all over. So let's talk about the software interface for PMX. PMX have a multitude of layer software interface available. both for end users as well as for test systems integrators. If you look at it, the primary software interface is, of course, web server based, which is what I'll show you today. But in addition, we also have the HBM Catman ED software, and that's a full-fledged data acquisition control type of software we can use. But if you were to program on your own using a .NET API, we provide that as well. This is not released yet, by the way. This is coming up summer of this year. We're also going to release a LabVIEW library summer of this year. And a soft PLC support using from Codesys will be also available summer of this year. In any case, all of these interfaces are available to talk to you with the PMX hardware. If you were to connect the PMX using the Ethernet port to a user interface available from various other vendors, like a touchscreen, you can use the Google Web Technology, which PMX supports. It's also the same technology that's used in your smartphones nowadays. So this is a screenshot of the PMX full overview that shows you all the internal channels, that shows you all the calculated channels, digital output, limit switches, FieldBus, etc. for your applications. You can have these broadcasters 24/7 while the application is being run. PMX also supports using the Ethernet port external devices such as your smartphone using Wi-Fi or an HMI solution like we talked about. When you go into the PMX and open up the web server, and I'm going to give you a few more details as we go through, it gives you 3 different levels of operation. And some of these levels are password protected. So there's an operator level, there's a maintenance level, and then there's an administrator level. Which is password protected. This is freely configurable, and this is the end user. So whatever you show in your operator in your interface is what the operator is going to be able to see and use. Test measurement is available for every channel, like shown here. But so if the channel was not connected or is not test compatible as you requested it to be, it will show you to be an invalid channel. There's also a system status available as well as a log file available. So anytime in the PMX in the bottom left-hand corner you see a green LED and you press that, it will give you the system status. And it has all the syncing, error, regulation, heartbeat, power, command interface, buffer overflow, everything available. So if something went wrong or did not work, it will highlight that right away and you would know that you need to go and fix that. In addition, there's also a log file. You can just look at who's been using it, who logged in last time, and all the details on that log option. So the web server configuration. So when you open up PMX and just type in on a web page PMX, that's 3 words, PMX, like I did by naming the device PMX, this is what you will see. The screenshot will pop up. You have an option of selecting you are an operator or a maintenance person or administrator, and then you will see a section of overview and settings. You'll see a system option, device option. Under device option, you can select the device name. In my case, I named the device PMX. Okay. There's system time, network user IP address issues. All the things can be configured here. If you want to update your firmware, newer firmware will give you more different type of calculator channels, more different calculation option, changing password, reset factory settings, device storage, etc. If you click on Amplifier, it will tell you the input and output amplifiers, the calculator channels. I'm going to spend a lot more time here now as I go through step by step. A FieldBus option that tells you you're in Profinet or EtherCAT or Ethernet IP, digital output, and any limit switches that you might define. So when you click on that overview of the amplifier, it shows you all these internal channels. In my case, I have an analog output, digital output input module, so it's a combination module. I also have a bridge module, so you can see the various bridge sensors that I've connected. I've also have a voltage and current input module, and my slot 4 is empty, so shows nothing. And here's all my different calculations, up to 32 different calculations that I can configure. I'm going to show that to you in a minute how to do that. some digital output channels, limit switches, and what FieldBus option I'm using in my system is an EtherCAT based. Here's my log, and here's the CPU load on the PMX. So there's pretty much no load because there's no calculation going on here. So the first step is to do the amplifier configuration. And I have a 455, which is a bridge module, and I've connected several sensors, a strain sensor, a force sensor, a displacement sensor. And this is, nothing is connected here, so it shows invalid. I can select what type of bridge it is, full bridge or half bridge, and the physical unit, micrometers per meter, newtons, millimeter, and then I can do my characteristics, my 2-point characteristics calibration basically, and my 0 point, what does it mean, and my for zero voltage, what am I getting, how many micrometers per meter, and for a known strain, what is my voltage rating. So this should be in the data sheet for this sensor that you're using, and I basically copied those. Same thing here, here, and same thing here, basically. You can zero the channel by hitting the 0 button, so there is no load on it, or no force, and no displacement. You can just hit 0 and it will zero itself out, so it will tear out. There are other functions, like if you didn't want to click on it and you wanted to do programmatically, you can do 0 by using a digital line, or clear the 0 by another digital input, or a test signal if you choose to do so. And here's what you name it. I named it strain SLB700. You can call it Tom, Dick, and Harry if you care to. And then there is some filters, analog filters available, Bessel and Butterworth, and you can define your cutoff channel. Of course, these don't really make much sense. I didn't even touch it. I just left it as is. But for lower bandwidth sensors, you could probably put, for example, strain. I would select this to be 200 hertz. And if this was a vibration sensor, for example, I would go more higher bandwidth, 2 or 3 kilohertz. Or if it gave me more options of higher bandwidth, I might go up to 6 kilohertz. It depends on what I'm trying to capture or acquire. Step 2 is output. Whether you're doing voltage output, analog voltage, digital output, or input. So that's the 878 module. And you tell them, in this case, what channels, the source for your output. So I've selected the same 3 channels, the strain and the force and the displacement. And then you can do your scaling right here and give it a name, like I've given it some different names. If you had a FieldBus, you may not have one, but if you do have a FieldBus, it will detect automatically for you. Is it an EtherCAT or a Profinet or Ethernet IP? You can define how many calculator channels do you want to share from your PMX to the other system, which is PLC based perhaps, and how fast can you poll. You can poll up to 250 hertz. And then the MAC address of the data of this bus and other details, which is just given to you for your own information. It also shows you the processor load during the communication process. There's the digital output configuration, and you can select the FieldBus is turned on or not, the limit switches are turned on or not, if there's a parameter set, if there's a calculator channel bit mask set, and which channel you're considering to use the digital output for. You can select from there as well. And here is the configuration for limit switches, very similar as the digital output, but now you can tell what is the lower band value of the limit, the hysteresis, if there's any reset to be done. I have chosen the 3 channels, the strain, the force, and displacement. In one I chose above level mode, other one I said I want to be within the band, and the other, third one I chose to be outside the band. So this is your limits that you're selecting. The last step is step 3 is the decision-making channels or calculation channels. In this calculation channels, I'm showing you 3 different calculations. The first one is the filtering standard input. So I've chosen a strain gauge input coming in, and I chose the filter, select the low pass, bezel type, cutoff frequency, and I say I'm going to output this filtered strain on channel number such and such, the decimal places, the units, and this update rate. Merely by points, click and go. If I were doing a peak value, which is very common in many industrial applications, I was measuring a force, what aspect of peak I'm measuring, peak to peak, or maxima, or minima. I can click from here and select that. And then where would the output be going to, the decision of this calculator channel. And I've chosen to go to channel number 2, and this would come out as a Newton at that sample rate. Now, a PLC can take that and say, okay, I better apply less load or less force to this press, so the pressing is done right properly. This is a little more complicated, a PID calculation. I didn't have a temperature sensor connected, so I just chose displacement, but it's a voltage at the end of the day. And you have all the various aspects of the PID controller, the KR, the TI, the TD, the set point, and the result channel coming on channel number 3, and how fast you can run. So to sum it all together, if I were to do a generic press application, which is what I shared with you earlier, my step 1 would be to acquire my strain channel, or maybe more than that. I'm just using one channel here, and configure that strain sensor. My step 2 would be the output, which is a force, output force, and I would do a digital output to communicate to the PLC-based system, and I would do a peak calculation using the calculator channel. Using the peak, the maxima, the input is my strain, and the output is my force. It's all done on a web server. You save it by clicking the diskette icon, which I'm not showing you here, but at the bottom there's a diskette. You click and save it, and it is running in real time. There is no more programming required. However, if I wanted to go and do a much more full-fledged, bigger application, I could use Catman or LabVIEW or .NET. I'm just showing the Catman interface. Same exact hardware. I ran Catman. It went and found my 3 sensors, strain, force, and displacement, and the other modules are empty. And I have the same options here, which is creating a calculator channel, in this case called computational channel, and it would show up under here. So the PID, the peak force, etc. will show up here. And I can configure everything and hit the start button. It will take all my configuration and deploy it on the PMX and run there real time and send me feedback and updates of my graphs. PMX also has diagnostics features. So if you were to log into PMX remotely, if you've deployed the system at a customer site, if you're a test systems integrator, for example, you have VPN tunneling options and IPsec options and authentication options. It works very well with your internal ERP system of the customer. So remote maintenance is very easy. So to summarize, PMX is the right tool for monitoring, pressing, and joining of many high-quality parts. So very, very important in the industrial application. It is also widely has been using for end-of-line test benches. So instead of doing a separate testing afterwards, you can do testing while manufacturing production is done. Outside the industrial lab, it is used for condition monitoring to prevent premature failure and extended life, like I shared with you with the windmill farm, as well as back in the lab on industrial test benches, where you can control your manufacturing tolerances precisely, reducing rejects while increasing yields and driving quality up higher. It is an ultimate device for measuring, controlling, and interfacing out of the box, so the software interface is really, really easy, like I showed you. And all of these inputs are reconfigurable outputs as well as interfaces, and it is a laboratory-grade hardware, although used in an industrial environment. Please visit www.hbm.com/PMX for further information. Thank you for coming.
All right, thank you, Sujit. If you guys have questions, you can type them into the Q&A period, and we'll answer the ones that we have time for here. Sujit, there's one question. An attendee has a quality assurance application where they want to measure the dimension and thickness of materials as well as tolerances. The sensors they're using are white light interferometers that give out a 0 to 10 volt signal. So he's wondering if PMX would be useful for this application.
Yes, it would be.
Yeah, basically they'd like to compare the data of a perfect QA specimen to the data collected on a new manufactured unit.
Yes, you can. PMX has a voltage and current input module, the 401. You would use that and feed in your output from the device, and you'd be able to measure it directly.
All right. Can you tell us what the difference between PMX and kind of a standard data acquisition system is?
Yeah, standard data acquisition systems are more geared towards usage in the laboratory or maybe out in the field in a mobile environment or rugged environment. But normal data acquisition systems are there to just acquire the data, bring all the information to your computer for offline analysis, and you would use various software routines to do so. PMX, on the other hand, is doing everything in real time, on the spot, making decisions for you, although you could store data and bring it back in the lab. But that's not primarily why people would use PMX in a real-time system like that in a production environment. The accuracy class of the amplifier from PMX is a little bit different than that of a traditional data acquisition system, which can be really, really, really low. PMX has good enough accuracy for the industrial applications intended for, and it has carrier frequency rejection technique to take care of amplifier and any type of noise interference coming from electromagnetic interference.
All right, another question. What's the average latency in the control loop?
Oh, that's a loaded, interesting question. It depends on a lot of things. Latency is determined by your input sensor, how fast it is sampling, the bandwidth of it, as well as your output, how fast are you sampling and the bandwidth of it, plus the time it takes for the data to be digitized and travel through the internal buses into the CPU, or the digital signal processor, and the most important being is how hard of a computation are you running in the digital signal processor. But for most simple applications, I've seen an average latency is around 1 millisecond or so, and give or take, some low, some higher. But without knowing more details, it's hard to answer the question.
All right. Well, everyone, thank you again for attending. I will distribute Sujit's presentation immediately this afternoon so that you have it, and I will also notify you in a few days once the full recording is available on our website. Thank you very much for joining us. Have a good afternoon.
Thank you.